Satish Ubare sir have been a tremendous support and guiding force for our program. Our guest of honor, Dr. Dhananjay Pingre sir and students of Matrix. Dear students, Matrix believes in leveraging the management competencies amongst the MBA graduates for business and industry by expanding their horizon with updated information in the field of management. In continuation with that, our Honorable Director, Professor Satish Ubare sir, has initiated 4 dimension session lectures where we invite renowned experts from different fields of academics and industry who share their experience with the students, which helps them to improve their knowledge and employability skills. It gives me an immense pleasure to introduce today's esteemed speaker, Dr. Dhananjay Pingre sir, a multifaceted professional whose contributions span research, consultancy, and academia. Dr. Dhananjay Pingre sir brings over 2 decades of rich experience across diverse sectors, specializing in qualitative and quantitative research methodology, CSR implementation strategies, and impact assessment. With a PhD in management science, an MBA in HR, and extensive expertise in analytics, grant writing, and financial projection. He has been a guiding force for numerous organizations and NGOs. He has trained over 900 plus HR managers, 1,300 contract laborers, and 600 women in entrepreneurship development using globally recognized methodologies, including ILO certified tools. Sir, intellectual pursuits are evident in publications, patents, and research projects. With his hard work, making significant contribution to journals and books in the areas such as human resource management, labor laws, and qualitative management systems. Today, we are really fortunate to have him with us to share his profound insights and practical knowledge. And before starting the session, we would like all the participants to please open up your camera so we can have a group picture with Sir. Students, yes. Mohit, so please let us know when you're done. Okay, so over to you.
Actually, students are not there. I think they are somewhere busy.
No, no, students are there, but not some are working also, na. So
Yeah,
that's why.
they cannot open their videos. Okay, no problem. So shall I start then?
Yes, sir, yes, sir.
Okay, thank you. So I'm just sharing my screen.
There is the
Okay, so my screen is visible now.
yes, sir.
Okay. Okay, so if you are following University Pune of syllabus, this particular test is used in the syllabus from Pune University under the subject of research methodology. We call it business research methods. So the topic I selected is the linear regression for business decisions. So this is the basically the formula that we are going to learn today for these business decisions. Everybody knows the regression. I think the students may know they very well, and but the greater insight is that where to apply this regression analysis, regression equation, and what is their benefits to get the how the business decisions are carried out with the help of this regression analysis. So it is very simple formula. As you can see, it's a y is equal to a plus bx. So if we see it like the formulas of the finding quotient of a and b, so we may see it's very difficult, it's very, we cannot understand it, but this is not the case. So that's why I selected this method of delivering session with the help of hands-on training. So I required everybody to be there to focus on this session and get a greater insights. They can ask me questions also, it will be easy to throw up a specific light on the particular issues that raised by the students. So before going to the theory and this thing, I don't want to get much into it. We will just shift to the practical insights of the regression analysis. So for example, we'll start having an example here in Excel. So I hope everybody is able to see my screen and the Excel sheet that I opened on my screen. Is it visible? Excel sheet is visible?
Yes, sir.
Yes, sir.
Okay, very good. So, for example, it's a very simple example that I am going to tell you. On that basis, we will understand how this regression analysis is used in the business scenario. So, it's a very, very natural and normal example that we are going to try here. So, this column tell us the advertisement expenditure, and this column tell us about the sales in INR, right? Sales in INR. Okay. So if I say advertisement expenditure is 10 rupees, my team has successfully made a sale of 100 rupees. When I put 20 rupees as an investment for the advertisement expenditures, I got 200 rupees sales. If I put 30, I got 300. I put 40, I got 400. If I got 50, I got 500. Now my question is, if I put 70 rupees as advertisement expenditure, then what would be the sales? Anybody can unmute themselves and throw answer. Okay, what is the exact sales that would be there after putting 70 rupees as the expenditure for advertisement? No answer? No guess? No guessing?
700.
Very good. It's very easiest way to say 700. Now, I would like to mention that whenever you are going to answer this, you have utilized regression analysis in your mind. And this regression analysis, if we put in a mathematical way, it shows like this. So, which is better? To understanding regression by using formula is better, or predicting values like this is better? It would be gonna interactive session. I'm not going to only speak here and you are going to listen or neglect. You should be answering my question so that the learning would happen. So what is your understanding? Is it easy to have this kind of exemptions examples and estimation about the sales by using regression analysis? What do you understand? Is it easy? So what exactly you people had did, you just made advertisement expenditure multiplied by 10. Am I correct? I have mentioned 70 rupees, you multiplied it by 10, it gives you 700 rupees as a sales, right? So 10 is the multiplier. 10 is the multiplier, correct? ये जो सेल्स है एडवर्टाइजमेंट जो सेल्स है इट इज 10 टाइम्स टू द एडवर्टाइजमेंट एक्सपेंस 10 गुना ज्यादा है एडवर्टाइजमेंट एक्सपेंडिचर से. Am I correct? Do you have any difficulty in English? I can tell in Hindi also and Marathi also. But you please understand it from the point of your business decisions. So up to this, it looks very easy. Am I correct? It's very easy. Okay. Okay. So I am visible now also, right? So if you see here, we have put this advertisement expenditure into 10, that gives us the sales. So my question is how we calculated this multiplier 10, right? So if you refer the formula here in my presentation, y is equal to a plus bx, right? So here y is equal to a plus bx. This is the value. So y is equal to sales. Y का मतलब है sales, that the figure we would like to interpret and predict, and x is obvious advertisement expenditure, right? So what we did multiplier. The advertisement expenditure means y, we have mentioned x here, advertisement expenditure is x, is say 70, and multiplied is 10. So in this formula we can write in a different way, like sales is equal to a plus b multiplied by advertisement expenditure. Okay, now is it easy to understand? Is it easy to understand? The formula that we have mentioned here, y is equal to a plus bx, we have converted into our own example in a business scenario, that sales is equal to a plus b into advertisement expenditure. Now, in this example, we have received sales is equal to a plus the beta value, which is represented by multiplier into the the advertisement expenditure 70. Now sales, we can write this way, sales is equal to a plus the multiplier we have arrived at 10 into 70, which gives us sales estimate of 70. So is there any difficulty to understand at this level how we arrived at the 700? So if I put here 80, so you will obviously tell me that sales would be 800, right? Am I right? Am I correct? If I mention 80 as advertisement expenditure, the sales would be 800 rupees. How we did it? If we put in a, it's a logical one, right? It's a logic. We just applied logic. 10 का 100 है, 20 का 200 है, 30 का 300 है. So in this way 80 का 800 है, हमने 10 times कर दिया. But when we use the mathematical expression, we have to use y is equal to a plus bx, or sales is equal to a plus b multiplied by advertisement expenditure, and this way we will get the figure of sales. So now what is the challenge? अभी सब easy दिख रहा है ना, it's very easy to understand. So if I shuffle the figures like this, if I shuffle the figure like this, and now I wish to put my 70 rupees as advertisement expenditure, and now you tell me what is the estimated sales. Can you tell me what is the estimated sales? You can message into the chat box also, that would be also welcome. Chat box, you can put your text message in the chat box, right? So when I shuffle these figures, it is something difficult to predict the value, which was very easy earlier. So every businesses are trying to figure out their future based on the statistical tools, mathematical tools. to make a business planning a very fruitful decision, right? So we have taken this example of advertisement expenditure and sales. There are many things that we need to understand before going to make a business decisions. So for this example, this advertisement expenditure is a variable and sales is also a second variable. These are the variables, right? Advertisement expenditures and sales. The quality of the advertisement sales and expenditure, it is to be measured, right? It is to be measured. There are many methods for measuring the figures, like nominal, ratio, and uh, there is a four scales actually. The first is the nominal, interval, ratio. So in the nominal scale, the figures given are just yes or no type. This is just a labeling kind of thing. Then in ratio scale, we are getting the entire zero of starting of the scale. So this advertisement expenditure and sales are the good example of ratio scale, right? And there is interval scale. So we use always a Likert scale to measure the behaviors and the attitudes of the people. So that is measured based on the Likert scale. So for this regression analysis, we always expect the ratio scale is to be utilized for better prediction of the future, right? So when we look at this figure, it is we again come to our first question. Given this kind of data, it is very difficult to estimate the exact sales figure based on this past experience of data, right? So whenever we are going to solve this business case, we have to use regression analysis, right? So I will give you the glimpse how we could understand this, right? So I'm again going to have this earlier example for the better understanding, right? I will remove these figures. Now, when you look at closely to these two figures, it is very appealing that there is a relation between these two variables, advertisement expenditures and sales figures, right? So how we can arrive at this kind of advertisement expenditure and sales kind of stuff? So let me start. I think my the pen brush is open to and they can see it, right? Is it visible? I need answers, please. Huh?
Yes, sir.
Okay, you should talk to me. Otherwise, it's very difficult to deliver a session without interaction, right? For this, at least for this regression analysis. So everybody knows what do you call this axis? X-axis, and this axis is called as Y-axis. So what we are going to do, we are going to plot this data onto this chart, right? So this way, on x-axis we will plot advertisement expenditure, and y plot we put the sales figure, because y is the predicting variable that we are going to use, right? So in this way, if we put here advertisement expenditure, which is 10, 20, 30, 40, 50, 60, right? And the sales figure are 100, 200, 300, 400, 500, 600, right? In this way we are we can plot the figures. Now, when you make a graph out of it, what we will see, look at the data first. Advertisement expenditure 10, sales 100, right? So advertisement expenditure is here, sales is here 100. We'll change the color here, right? Then 20 to 200, 300, 40 to 400 something. Just try to understand the, okay. So this way we can plot the data on this graph paper and we will easily get this line. You can touch the dots this way. Okay. Uh, Now is it clear? So relation between sales and advertisement can be represented by with one single line. So this single line is referred as regression line, right? And mathematically it can be expressed as sales is equal to A plus B into advertisement expenditure, right? So this way we can draw a regression line, but which is only available for this kind of data which having a relationship between them. Okay. So if we want to measure this relationship between these two variables, we need to run another test. We call it a correlation analysis. So if you go to the data analysis, then correlation, we have to select input range, which is this one. Now labels are there, output range, new workbook. Okay. So this way we can find the sales and advertisement relation are having 0.98. So what we can say, we can interpret that advertisement expenditure is having 100% correlation with sales. Okay. So what does it mean? This 98 reflect that, 91 reflect that if 1 unit of change in advertisement expenditure, 1 unit of change in advertisement expenditure will increase equal unit of change in sales. So if I put 10, sales will be multiplied by 10, right? I will put 20, it would be 200, 30, 300 for this simple meaning. Okay. So the first assumption while using regression analysis for decision making, there should be a correlation between the variables that we are using, right? Now getting this B, you understood, right? So what does it mean by A and B? That is the most important question. So in statistics, in regression analysis, this line is a regression analysis, right? Regression line. We call it a best fit of regression line. Now, assume a business scenario where there is no expenditure on advertisement is incurred. कोई एक्सपेंडिचर खर्च नहीं किया एडवर्टाइजमेंट में, सो विल इट बी कि कोई सेल्स भी नहीं होगा? There are many examples of businesses that run their own, but they don't advertisement. They don't put expenditure on the advertisement. Even they got the sales figures, right? So what it will be happen? So if you draw in business scenario, regression line will not be like this: zero expenditure, zero sales. No, there always be some sort of sales occurring in the business. So most probably regression, if you say, if you draw like this, what we understood, if there is no advertisement expenditure, right? When there is no advertisement expenditure is zero, even though we are able to make a sales of 100 rupees, right? So this is the constant sales without any effort, without any effort put by the team, without effort of any salesperson. We got 100 rupees sales. So this 100 rupees sales without any expenditure, without any advertisement expenditure, we represent as the A. So A in this regression analysis is called A is equal to A. A means constant. A means constant. Right? So this A is calculated based on the previous experiences. So if you look at this data, we have given input to the Excel sheet 10, 20, 30. Based on these observations, regression analysis can tell us what is the constant for this regression analysis. Constant means fixed sales. There is no requirement of advertisement expenditures. Now, what is beta? Beta is basically the slope of this line, either this, either this, either this, either this, right? So it may start from here also or there also, right? So if you look at this example, the starting point of the line is called a constant and ending of the point is reflected as the slope, and this slope is represented in this regression analysis with b. We call it a beta value. B is equal to slope of regression value. Now finding out the constant is very easy. You can just look at the y-axis where the line it touches. You can say this is the constant, right? But finding out the beta value required certain kind of correlation calculations, right? So this is the simple example of correlation. So when we have the data like this, if we plot a data and we received the examples like this, is it visible? I think it should be size. I should increase. Yeah. So if I got this kind of data, the plot that we have made based on the graph. Now, in this example, it is much challenging to draw a one single line to fit to touch all the dots, right? So it's difficult. So what we try with the regression analysis, we put our efforts to make a line close to maximum dots, right? So in this way, if I draw a line like this, got it? So what we are trying to do, we are going to measure the distance of every dot to line, distance of every dot to line, distance of every dot to line. This distance is called as a variation. This is the variation among the variables. So this variation should be minimum. We will try to put the variation at the minimum level, right? So first of all, whenever we calculating this regression analysis, we must calculate the correlation coefficient of the data to understand the relationship between these variables. Now, very simple question I'm going to ask you, and you please answer this. If height of the person, height, the measure in feet or inches, if the height if the height is increases, this that means weight is also increases. दिस इज राइट और रॉन्ग? अगर किसी का हाइट बढ़ता है तो उसका वेट भी बढ़ेगा, राइट? विल इट इंक्रीज और नॉट? I need a answer please, whether height is increasing, weight also increasing. Am I right or not?
Yes, sir.
Okay. But if you say if weight is increasing, does it mean that height is also increasing?
No,
अगर
sir.
हाइट बढ़ रहा है तो वेट बढ़ रहा है, बट वेट बढ़ रहा है तो हाइट बढ़ रहा है, ऐसा बोल सकते हैं हम लोग? कैन वी से
Yes,
दैट?
sir.
नो, इट इज नॉट द
No.
केस. करेक्ट, यू आर वेरी राइट, वेरी ट्रू. ऐसा केस नहीं है. द सेम वे, इफ वी पुट एडवर्टाइजमेंट एक्सपेंडिचर एंड सेल्स इंक्रीजेस, बट इज इट ट्रू दैट सेल्स अगर बढ़ेगा तो एडवर्टाइजमेंट एक्सपेंडिचर बढ़ा ही होगा? दिस इज नॉट द केस, राइट? अगर एडवर्टाइजमेंट का एक्सपेंडिचर बढ़ा तो सेल्स बढ़ा है, बट सेल्स ज्यादा हो गया, इसका मतलब ये नहीं है कि एडवर्टाइजमेंट का एक्सपेंडिचर भी ज्यादा हो गया. मे भी हो सकता है, मे भी नहीं हो सकता है, राइट? ओके. So this way we have to understand first the correlation, type of correlations. So I will then bring to my presentation where I drawn some samples, right? Is it visible now? So first when you look at here, I can use markers here, na? Yeah, you have mentioned messages, very good. Okay. There is a tool, but in this way, not understand. Okay, no problem. So this example, this first example, I will explain you. Okay, not opening here. Okay, no problem. So this example of advertisement expenditure and the sales, uh, where you can correlate it. Is it a type of one, two, three, or four? There are figures I mentioned here: one, two, three, and four. So what kind of relationship we have established in this example? एक जो एग्जाम्पल था इसमें आपको कौन सा लगता है, कौन सा होगा इसमें? ये जो रिलेशनशिप है, ये कौन सा है? एक में आएगा, दो में आएगा, तीन में आएगा? एक दो तीन चार. कैन यू speak, because I cannot again open the Zoom and again see it. So if you say, you can say 3, 2, 4, 1. किस में आएगा ये? Okay.
I think in two. In
Okay.
figure number 2.
Very good, very good. It is close to second type of medium positive correlation. But in statistical point of view, it is coming under the first type of correlation, large positive correlation. What is it? Large positive correlation. If you can look at here, it is 98%. 98%, right? So if correlation is between 80% to 100%, close to 100%, we call it is a large correlation, right? So type 1 wala correlation. What is type 2? It is between 70%, sorry, 60% to 80%. We can call it as a medium correlation. Okay. This figure I am actually I am talking about this particular figure, sales, right? Medium correlation, 6 to 80%. Then if it is between 30 to 50, 30% to 60%, we call it small correlation or minimum correlation. Minimum. If it is between if it is between 20% to 30%, we say like weak correlation. And if it is 0 to 10, it will be no correlation. Okay. Now in our case, we received correlation coefficient as 0.98. That means 98% of correlation. So this will easily reflect that our correlation is large correlation, right? Now I will shuffle the figures and we again calculate the this correlation, right? For your understanding. Right? I just shuffle the figures here, advertisement expenditure, and I'm going to run the this test again. So now correlation coefficient, how much we received? We received 0.43. Means now the correlation is 43%, right? So अगर ये 43% है, तो where it would fit? It would fit on the here. It would be minimum correlation, right? Minimum correlation. Okay. So so this way you could understand regression analysis is actually used to actually based on these correlation coefficients, right? Now when I ask you a first question, prospective what is the prospective the predictive sales figure, you were easily answered because there is a perfect correlation. But when I shuffle the data, you cannot answer the question of predicting sales because the correlation was weak between the variables. The correlation was weak between the variables. Now, the regression analysis help us to answer help us to answer why this variation caused. Why this variation caused? 10 एडवर्टाइजमेंट एक्सपेंडिचर था 100 सेल्स हो गया 20 था 300 हो गया 300 से 300 why 300 why it should not be 3000 it is to be 3000 and multiplied by 10 so now tell me if there are I will be adding one more variable into it in number of salespersons right so here there is only two salespersons here two salespersons and now here three salespersons again two one two and 30 and 4 6 70 and 8 so these are the number of salespersons what we could see here advertisement expenditure budget is 10 rupees per salesperson right that is to be there but when we added 30 salesperson sales have not increased so if you calculate again the correlation for this data we will get a better understanding right just like here. Now we can evaluate and interpret the data here okay so look at these figures from this right first of all we are going to here advertisement expenditure and sales are having correlation of 43%. That means the variation in sales figure caused by advertisement expenditure is 43%, right? Then number of salespersons and sales is again very much correlated. It's again 43%. Number of salespersons and sales. Because the number of salespersons varied, it is again varied into the sales, right? 300. So, and if you look at the advertisement expenditure and sales, it is the perfect correlation. Here we can see a perfect correlation. It means 0.1. यहाँ पे correlation एक आया है advertisement expenditure का और number of sales का, right? क्योंकि जिस प्रोपोर्शनेट से हमने एडवर्टाइजमेंट के एक्सपेंडिचर बढ़ाए, सेम वे वी इंक्रीज द पर्सन. द ऑब्जर्वेशन दैट वी मेड अर्लियर इज 10 rupees per salesperson was the budget, right? So if I again shuffle the data, and make here like this, the salespersons are constant. Now you tell me what is the what is your observations on this, on these sales figures? What is your observation? Now the scenario is clear. एडवर्टाइजमेंट है, सेल्स है, एंड नंबर ऑफ पर्सन भी है, सेल्स पर्सन भी है. बट नंबर ऑफ सेल्स पर्सन वी केप्ट कांस्टेंट. We never changed the persons. We just adjusted the advertisement figures. Advertisement expenditures were adjusted. So this way we can easily understand the effect of advertisement expenditure. So if we again calculate the correlation coefficient, let's have a quick look into it. Okay. Now if you see, number of salesperson have mentioned division by 0 and sales division by 0. So number of salesperson have not been considered as the variable. Number of salesperson have not considered as a variation because there is no variation into it. That's why it has not calculated, right? So if again we make some a little change into it, and 3, right? We'll again calculate the correlation coefficient. No. Now we are able to calculate the correlation coefficient. Okay. So what we can see, sales and advertisement expenditures are 43% correlated. Number of salespersons and advertisement expenditures are 88% correlated. Now there is a catch. Number of salespersons and sales does not have any relationship. Number of salespersons and sales figure is not have any correlation. That means if we want to increase the sales by adding a salesperson, that would be our wrong decision. Am I correct? Are you getting my point clearly? हमने अगर सेल्स पर्सन बढ़ाए, नंबर ऑफ सेल्स पर्सन बढ़ाए, तो सेल्स नहीं बढ़ेगा. इज दैट द केस? यस. यहाँ पे 2 सेल्स पर्सन थे, सेल 100 था. 2 सेल्स पर्सन थे, सेल्स 300 था. 3 सेल्स पर्सन कर दिए, एडवर्टाइजमेंट का एक्सपेंडिचर भी बढ़ाया, फिर भी सेल्स इज 300 रुपीज ओनली, राइट? यहाँ पे वी पुट 3 सेल्स पर्सन एंड वी इंक्रीज बजट टू 700 rupees, though sales has not been changed, proportionately not changed. It should to be changed in proportion to advertisement expenditures, right? So this way, this is the combination of relationship of these 3 variables, right? So I think you must understood what is the correlation and its role in predicting the situation of business scenario. Is it right? Is it okay? Up to this, you're clear. You're okay. I need answer, please. We'll have only 15 minutes to complete this session. Up to this point, have you clear what are the variables, the role, and how we are going to put the decisions, right? Uh, shall I move ahead? I think we should move ahead. There is no response from you people. Am I connected? I am audible?
Yes, sir. Yes, sir.
अच्छा, ये आंसर आ गया. ममता मैडम, थैंक यू. ओके. I know it is a little bit heavy to digest this, uh, online mode also. There you have to keep very focused by doing other stuff sitting at home. So what we are going to do, we are now coming to our particular session of regression analysis. So having perfect correlation, significant correlation is one of the important assumption to run a regression analysis, right? So now let's have a regression analysis itself here. Okay, so again we are going to the menu data. Actually, this session should be in a computer lab. So you should have a laptop with you and you can get a clear insight into it. So in data analytics tool pack, there is a regression. We have to select it. Then input Y range is the sales. Input X range is the advertisement expenditure. Yes, there is a label confidence interval 95%. And this plotting we are not going to talk right now. It will be confuse you. Okay, this is the output that we received for this regression analysis. Is it visible now?
Yes,
Hmm?
sir. Yes, sir.
Okay, very good. So now we are going to interpret this data so that you could make a sound decisions for your businesses, right? So first of all, ANOVA we are going to remove. It is not required to interpret this regression. We will keep ourselves limited to the regression statistics only. Okay. So as I told you, the in regression correlation is most important. So the regression analysis automatically calculates the correlation. So where is the correlation? So this figure multiple R is the correlation. Okay. So what is the correlation here? 97, right? 0.97. This means 97%. So in your example, advertisement and sales are correlated. How much? 97% they are correlated. This means if we change the advertisement expenditure, 100%, 97% sales will be changed. If I put here 90, sales will be 900, right? So this is the case here. Okay. Now the next, what is this R square? R square is the cause of variation. I have told you कि in the example of weight and height, I told you अगर वेट बढ़ता है तो हाइट बढ़ती है बट हाइट बढ़ती है तो वेट बढ़ता है ऐसा नहीं है बिकॉज increase in weight doesn't depend on this weight but increase in height increase in weight maybe depend on the height but increasing height does not correlated with the weight. So this way this adjusted r square this r square gives the reason for variation into data of cells. So this way 95% variation is caused by advertisement expenditure. What does it mean? ये जो सेल्स है 100 रुपए से लेके 900 रुपीज तक गया ना ये the increase in the sales from 100 rupees to 900 rupees is caused by advertisement expenditures. But how much it cost? It cost only 95%. 95% variation in sales is directly caused by advertisement expenditure. So this figure shows us the R square. Now what is adjusted R square? So this is the role of other exogenous variable. The figure is 94%, right? 94% role is of other variables. This has been mentioned by R square. So how we are going to interpret? अगर 95% एडवर्टाइजमेंट एक्सपेंडिचर से है और 95% adjusted R square, the difference of this, the difference of this, how much is 1%? So 1% variation in the sales figure are caused by other variables. Other variables in our earlier case was salesperson, right? सो अगर इतना स्ट्रॉन्ग कोरिलेशन है 97-95%, और ये जो एक्स्ट्रा वेरिएशन है, इफ इट इज ओनली 1%, we should focus only on putting efforts on advertisement expenditure. So we can suggest company, you can put thousands of rupees on advertisement expenditure and you can fetch a sales in this way. You can 10 times you can increase the sales if you put advertisement expenditure, but that would not be a logical decision, because sales is not only depend on the advertisement expenditure. Many variables are there, but we are limited ourselves to a simple regression technique. That's why we used only two variables, but there are multiple regression analysis also there. We can run the test for this also. So यहाँ तक आपको आई थिंक समझ में आ गया कि कोरिलेशन 97% है, बिटवीन वेरिएशन 95% है, adjusted R square 1%. What we say, advertisement expenditure and sales are correlated 97%. They are 97% associated, but the cause of variation is sales expenditure, and other variables plays a 1% role. Is that clear up to this point? Now, what is standard error? Standard error is given by 56%. So we have limited ourselves to get the observations of 9 months data or 9 days data or 9 years data. So this 9 months will not give an exact idea about the entire sales figures. If we keep increasing the input, if we fetch previous data of 100 months, 200 months, 300 months, then in that time we will be more accurately predicting the data for future, right? So our sample size is very minimum. It is very, very, very minimum. Sample size is very minimum. Set of 9 observations, right? We have used set of 9 observations only. Sorry, 8 observations only. If we have 8 observation, again 8, again and again 8. If we go up to the 100 set of observations, reflecting to the reflecting to the if you go to the 100 sets of observation by having total observations of 800 months, if you say it's the month of January, February, March, April, and so on, if we use the January to August data, but we need more accurate observation, we have to get other data. So we take this for 2024, again we take 2023, 21, 20, 19. So in this way, if we calculate, get the 100 sets of data accommodating 800 months, we will have some error of prediction, right? So this correlation, cause of variation, role of other expenditure may be close to accuracy. So in this data, due to its very small sample size we have considered, it gives us the standard error of 56%. So there is a chance of 56% error while estimating the sales figure. So up to this point you are analyzing the correlation only, right? So our correlation is perfect. Now we are going to interpret the intercepted advertisement expenditure. So in this example, intercept is mentioned as 42. So as per our formula, sales is equal to A plus B multiplied by advertisement expenditure, right? So where, how we do put the figures? So sales is equal to A. I told you A is the intercept, right? This is the intercept. Intercept means ये chart पे देखेंगे तो ये point on the chart. Intercept means this point where the line touches, right? This point. So in this example, intercept is 42.46. Now, so if this intercept is 42.46, what does it mean? It means that in this data, if you have not spent any single penny on this advertisement expenditure, zero is advertisement expenditure. Till that point, we will be able to make a sales of at least how much? 42 रुपीज. हमने जीरो खर्चा किया एक्सपेंडिचर पे, तब भी हमारे पास 42 रुपीज का सेल्स होगा, राइट? दिस इज रिफ्लेक्टेड फ्रॉम दिस इंटरसेप्ट. गॉट इट? कोई आंसर नहीं दे रहा है. एनीवे, so this intercept, then adding this, the slope of the line, which is calculated as 9.04. So beta value is here. This is the beta value. We call it slope, right? This is the beta value slope. So sales is equal to 42.46 plus slope of 9.04 multiplied by advertisement expenditure, right? Now, if we got this regression line explained this way, and if I want to predict the sales for 998 rupees of advertisement expenditure. So, given this data, I want to estimate the sales figure for this 98 rupees, right? So, if you go to the again the formula, now 9.04 multiplied by 98 of advertisement expenditure. So how we will get this data here? Yes. How much will be the sales? Sales will be 928 rupees. Sales will be 928 rupees. Why 28? Because the correlation is weak, right? It is to be 980. As per our estimation, na 10 times करना है ना हमें. So our logical thinking, it should be 980. But the regression variation is only 95% because of the advertisement expenditure. You got my point clear? So this way, we will use this regression analysis for business decisions. And my dear friends, this regression analysis is one of the algorithm used in AI, artificial intelligence. Now there is everything, everybody is talking about the AI. This is one of the algorithm very precisely, frequently used by the mathematicians to develop any algorithm for predictions, right? Okay. Now we'll just explain these further figures and we'll stop the session, right? So here I have mentioned you how to utilize regression analysis for predicting the sales and business decisions. Okay. So this coefficient of 42% is having 44% of standard error. That is huge. The T statistics is given by 95% and P value is 38%. So what is the role of this? So if we have p value of this nature, that is 0.38, which is obviously greater than 0.05, obviously greater than 0.05, this means we are rejecting this model. We are not going to use this model. Whatever it is going to give as the output of the sales figure, but the probability of p value is 38. It is estimated to be less than 0.05 because we are not, this is not a significant one because standard error is higher. It's very higher. So now standard error is 44. coefficient is 42. It is so lower confidence of this coefficient. This coefficient is again minus. So in our model, if we don't put any advertisement expenditure, the model tell us that our sales figure can be negative. How it is possible? It is definitely not possible if we don't put any advertisement expenditure. लोग हमारे दुकान से जो चीजें है वो उठा के नहीं लेके जाएंगे. They are not picking, not stealing. Confidence level, right? So lower है minus में है, so ऐसा नहीं हो सकता. So that's why we are going to reject this model. Now, advertisement expenditure. The slope is 9. So in this, standard error is 80 and p value is 0.0000, which is definitely a less than 0.05. So that this particular figure we are going to accept in our model, right? We are going to accept in our model. We are going to accept. Again, lower level is 6.77. So if you add any number of the advertisement expenditure, your sales figure is going to be increased at least by 6 rupees or maximum to 11 rupees. So this is the upper and lower interpretation is there, right? It is to be increased at least by 7 rupees to 11 rupees. If we put one additional rupee into the advertisement expenditure, but intercept is giving a wrong answer, so that the suggestion as a statistician, as a researcher to the business team is to add one more variable into it, so that the standard error would be minimum and adjusted as score will be healthy one. So this way we have to add one more variables here and increase the data to get a clear regression variables calculations to predict the model, and then this model will be used as the regression analysis, right? So this is the all about the regression. If you have any questions, you can ask me. Otherwise, it is to be handed to the Murali ma'am. Murali ma'am, are you there?
Yes, sir. Yes, sir.
Yeah. So it's done. If they have any question, they can ask me.
Students, do you have any questions? You can please ask, sir.
I'm confident that
Otherwise,
they don't have any questions.
they have understood the session very well then.
It's the question of regression again.
That's why.
Yeah. Okay.
Okay, sure. Okay, then we conclude the session, sir.
Yeah. Yeah. Thanks.
Okay. Thank you so
Thank
much.
you.
Thank you so much, sir, for accepting our invitation and for sharing such profound insights on the regression analysis. The session was really very informative and wonderful. On behalf of Metric School of Management Studies, I thank our guest of honor, Dhananjay Pingre sir, for guiding the students. I thank our director and express my gratitude for the
Yeah.
support and direction throughout the session. Thank you so much.
I also would like to get this analysis of feedback form.
Yes, sir, of
Yeah.
course. Yes,
Just
sir.
few things, and it is to be transparent, whatever it may be.
Yes, sir.
Hmm.
Definitely.
Okay.
Okay.
Thank
Thank you
you.
so much.
Thank you. Bye
Yes.
bye.
Students are requested to please fill the feedback form. अनिकेत माहिन कौन है?